Hi, I'm John Pedicino, Professor of Astronomy at College of the Redwoods. This YouTube series will cover material that we cover in our Introduction to Astronomy class, from a meteorite found in Antarctica from the planet Mars and the search for life, all the way through to supernovas and black holes. Let's talk a little bit about how science does the measurements that it does, specifically what units we use. And of course, like most of the world, we're going to use the metric system. Reminding ourselves, of course, that the baseline unit of distance in the metric system is the meter. 1 meter, of course, equals, as we talked about 3.25 feet. That means that 1,000 meters, which of course is 1 kilometer, equals approximately 3,250 feet. Compare that to the 5,280 feet in a mile, 5,280 feet, and we recognize that 1 kilometer is approximately 0.6 miles. So again, you're expected to be able to make a conversion of that. 1 kilometer equals 0.6 miles. You got an asteroid that's 100 kilometers across. It would be 100 kilometers times 0.6 miles per kilometer, and you've got yourself about 60 miles. So a 100 kilometer wide asteroid, about 60 miles in diameter. We also talked briefly about the units of mass in the metric system. We discussed it as weight. There is a difference. We'll talk about that later. But 1 kilogram, the units of mass, 1 kilogram in the metric system equals about 2.2 pounds. And again, you should be able to recognize that. You read in the text that you're talking about a 10 kilogram asteroid or meteorite. 10 kilograms, 2.2 pounds per kilogram, you're talking about 22 pounds of rock. Okay? So units of the metric system, important, units of distance, and units of mass. We're also going to talk about units of temperature. There are, of course, 3 different ways to measure temperature. There's Fahrenheit, there is Celsius, and lastly, there is Kelvin. Okay? Just as a reminder for comparisons, degrees Fahrenheit, degrees Celsius, and Kelvin. Couple matchup points: 32 degrees Fahrenheit, which of course is freezing, is 0 degrees Celsius. 212 degrees Fahrenheit, which is boiling at sea level pressure, is 100 degrees Celsius. That is a difference of about 180 degrees Fahrenheit, a difference of 100 degrees Celsius. So we recognize here right off the bat that Fahrenheit is a slightly smaller unit of measure than the degrees Celsius. But of course, in this class, we're going to try to use the 3rd unit system, which is Kelvin. As a reminder, 0 degrees Celsius is 273 Kelvin, and 100 degrees Celsius is 373 Kelvin, for again, a grand difference of 100. Telling us that a degree Celsius and a degree Kelvin, or a degree Celsius and a Kelvin, are in fact the same unit of temperature difference. The big difference here being that they are offset from each other. So if we wanted to convert degrees Celsius to Kelvin, all we would do is add 273, and we come up with Kelvin. So that's the formula if you're thinking about that. So this classroom today is about 68 degrees Fahrenheit, room temperature, which is about 20 degrees Celsius. 20 degrees Celsius is 293 Kelvin. That sounds pretty hot, but in fact, that is room temperature, 293 Kelvin. So why have another temperature scale if they're set up the same way? The simple answer is that Kelvin has something quite important, and that is absolute 0. So 0 Kelvin, which is equal to minus 273 Celsius, is absolute 0, which sounds very official. Okay? What it's telling us, though, is all about what temperature is a measure of. Remind yourself that temperature is a measure of energy. It's a measure of motion, how fast things are moving. And so it makes sense that as temperature decreases, that motion decreases. At some point, we're going to hit a point where nothing is moving. That is, as we discussed in class, absolute 0. So it's a much purer form of measurement for temperature. Okay? Quite honestly, you want to measure temperature has no motion, no energy, on up.